Okay. Hi everyone. So welcome to the session. My name is Yamini Pradhan and I will be your coordinator today. So what's today's topic? I think the topic is quite interesting. So in today's world, when we are diving in the most essential shift, that is the most important thing in today's world is data. Whether it's AI, whether it's cloud, whether it is mobile apps, everything works around the world that is what called as data. Now, this modernizing data is what is the core concept of today's seminar. As an organization, when the organizations are moving away from traditional centralized monolithic data systems, a new paradigm is emerging, which is scalable, which is domain driven, and built for self service. But at the heart of these entire transformations are two powerful concepts. One is data mesh, and other is data product. The benefits of this modernizations through this data mesh and data products are decentralized ownership, better quality, faster insights, and many other. So this it's a very important topic. It's a very core topic, and nothing around in today's world can be done without data. So anything and everything in today's world is only data. Data is as important as a currency. So to take us through this exciting topic, we have our today's speaker, Arnab Choudhury. So I'll welcome Arnab and I'll just give a crisp or brief overview of Arnab. Arnab is an enterprise architect in Capgemini with insights and data practice. He has around 24 years of IT experience. His expertise is mostly on data and analytics, which is the today's topic. He is expertise in providing solutions across industries, and he's an SME for data and IT innovation for data industry. I think let's welcome Arnav and we can start on today's topic. People can keep on joining. We have around 130 audiences till now and they'll keep on joining. So let's welcome Arnav and Arnav, you can take us through your exciting topic of uh, data mesh and data product. That is
Yeah,
data
sure.
estate modernization. Thank you.
Okay. So I will share my screen and I will start the topic. So I thought mostly this will be from the university, but I see a lot of architects and senior people have joined. So some of this might be little basic. Okay, so bear with me. So I have to just ensure that those who are not very familiar with these things actually they also understand these things. Um, so we will cover some basic things as well as some advanced things both. You can, I will probably take around 45 minutes or so, and then we will have 15 minutes of Q&A. That's the plan. We will see how it goes. I hope everyone can hear me, right?
Yes, Arnav, we can hear
Yeah,
you
okay,
loud and clear. Thank you.
cool. Okay. So let me start. So here we are actually we will deal with this topic of data estate modernization. So how enterprises can actually become data driven by adopting data mesh and data product architectures, right? So that is the topic we are actually going to deal with. Now, first actually we need to understand what is the business drivers for data estate modernization. What is actually we see like a lot of organizations going through uh, this modernization journey, right? So earlier, these organizations did have a data estate. They had some kind of a data warehouse, data marts, etc. for some business intelligence, right? So why they are actually kind of going through this modernization journey? Now, if we summarize, right? I mean, again, there can be specific reasons actually for some organizations. But if we summarize, then we will see that one problem most organizations faced is actually the cost of on-premise platforms. and infrastructure both actually, because all their legacy stuff, whether it is a data warehouse, data mart, whatever be it, actually were all on-premise data centers. So managing these data centers and their infrastructure, managing all these platforms, then the actual licensing of these platforms, right, is actually pretty costly. So, for example, when we see appliances like, say, Teradata or Exadata, right, these are actually very highly priced appliances. Okay, and infrastructure. If you want to add additional infrastructure in earlier versions of Teradata or Exadata appliances, right, it was pretty cost intensive and also time consuming. So so this is basically one of the main problem actually, like that most organizations faced. So whether they're really using that platform, right? I mean, they may be, their actual usage may be like a 30%, 40%, but still they are actually paying for the entire platform, which is actually very inefficient. Second is a lack of elastic scaling. So we actually see like each organizations are going through massive data volume increases, primarily driven by a lot of semi-structured, unstructured data. Even structured data is also growing as business grows. So earlier, this appliance-based kind of systems, right? Teradata, Exadata, Greenplum, these are actually pretty good from a scalability standpoint. Hello? Yeah, sorry. But when we see like a beyond 100 terabyte, 200 terabyte, their scalability was actually not so good. Uh, then they were not actually elastically scaling up and down. For example, like you want to run some heavy duty jobs or machine learning jobs, it's not like you can just scale up the infrastructure or platform very quickly, and once it is done, you can scale it down. That is not feasible. Okay, um, so scaling up and down is actually both time consuming and very costly affair. Hard, very, very problematic, and it actually, I mean, sounds weird, but I mean, these existing legacy systems all had a common problem, that there were data quality, maturity was pretty poor, and data governance was actually either very rigid, or it was actually very almost like a non-existent in many cases. So the problem is actually like a at that point of time, those systems were built. There wasn't actually much of a modern technology available for data quality or data governance. I myself had work actually where there were no catalog, no nothing actually available. So, so there were actually general lack of trust on the data from the users. They can see the data on the reports, they can probably verify with the source systems, but exactly what data they are consuming, they are not able to relate it to the actual sources, or they are not able to understand how this data was derived, right? So what is the lineage? There was no lineage. There is no definition of this metrics or KPI. So overall trust on the data is actually pretty low. Okay? And when trust is low, then data democratization, right? Which means basically everyone can use the data they require for their own either self-service or any other purpose. They can use the data for their functions. So that is not possible. Then legacy systems had a kind of a functional problem as well. Mostly those legacy warehouses didn't support any semi-structured or unstructured data, and that is a pretty big handicap from the sense that nowadays, as we see, like a in an organization, right? Majority of the data is actually unstructured. Okay, the structured data lies in some web app or some ERP, CRM systems, but the actual volume of data is in the actual documents, right? PDF or Word documents. So there is no way you can actually analyze those. Second thing is that okay, when Hadoop came into picture back in 2011-12, that time frame, that capability of unstructured data, semi-structured data was actually possible. But with legacy warehouses, that was not possible. Second thing is that processing in real time. So again, that was a problem with the legacy warehouses. So any real time on your real time or event-driven processing is actually not possible. Again, Hadoop started that capability, but there was actually quite a bit of limitation with that. But still, compared to warehouses, Hadoop provided quite a decent uh, capability. Uh, but Hadoop actually came with its own limitations. Lastly, when we think about slow ETL, ELT processes and isolated silos of DW and data marts that existed, right? I mean, there were pretty much a long list of technical depths as well. Um, but with the growing data volume, as we see, especially with say IoT data, clickstream data, that kind of data processing with the legacy ETL platforms is definitely not feasible. And again, these legacy warehouses, as we said, like had pretty much lot of technical depths. It ended up with a fragmented set of data marts with a poor kind of a conformance. So doing cross-domain analytics or cross-domain any business intelligence were also very difficult task. So overall, again, as I said, like there can be many other reasons, but you will find these are the very common kind of problems that we face when clients actually come back to us on we require to do the data estate modernization. Right? Now, what are the people, process, and technology focus areas for a data estate modernization? Now, if you see key success factors, right? People skilling, future architecture, improved self-service experience, time to market, like faster time to market, basically. You have to build small, scale rapidly, flexi ingestion, change management, one team approach. These are all very important success factors when it comes to data estate modernization. When it comes to the people, process, and technology aspects, right? From a people standpoint, if you do not actually invest on the skills and roles, uh, then you don't actually focus on building the culture and mindset to encourage a data-driven culture, right, within the organization. Um, have a kind of a train teams on like a cloud platforms, modern toolings, etc. Governance models, manage organizational change with a clear communication success metrics. These are very, very important part. Collaboration is another very important area uh, where actually things can really make a very big difference, right? Because eventually the data estate modernization is not just okay, you just migrate something from a legacy environment to a cloud environment, right? That is not a data estate modernization. So there has to be a focus on the people that involves basically all sorts of stakeholders, who the people who are actually developing the systems, the people who are actually going to consume these systems. So everyone has to go through this kind of a training and change management processes so that the adoption of this new system is actually faster and much more broader. Then only actually data estate modernization makes any sense, right? Otherwise, we are just investing a lot of money for no outcome, really. On the process side, actually, modern data governance is one of the key things. Having like centralized governance, data catalogs, lineage tracking, privacy security frameworks. Then we have the agile and DevOps or DevSecOps actually processes, CI/CD pipelines, cloud migration frameworks, data lifecycle management, and cost and performance optimization, which is primarily driven by FinOps processes, right? So these are actually on the process side, and finally technology side. So when we move into cloud native solutions, right? I mean, to leverage the power that cloud platforms actually provide. Um, so modern storage architecture, which is actually decoupled from the compute, so that compute can scale up and down without actually having any effect on the storage. Right? Then advanced analytics and AI incorporate real-time analytics, machine learning pipelines, and AI-driven insights. Integration and orchestration use cloud-based ingestion tools, event-driven pipelines, and low-code, no-code integrators. Security compliance implement identity-based access encryption, DLP monitoring, and compliance automation. So overall, if we focus on all three aspects from a data estate modernization, then only we will have a successful outcome. Otherwise, it will just land up in a again another kind of a chaotic outcome, right? Which is actually not going to serve the purpose from an organizational standpoint. Now coming to second part, okay. So and here there will be some basic things which experienced people will actually kind of already know. But we need to first actually see like, okay, when we think about a data estate modernization, so how these data and analytics systems, primarily data systems we will deal with, how these are actually have evolved over time and why this new thing which has come up in the last couple of years, right? Data mesh. What is the purpose of that? Now, I will not spend much time, but overall, from 1990s, right? When actually, if you remember, Bill Inman actually started the data warehousing concept, right? So from that time onwards, we have this enterprise data warehouse. Later on in 2000s, actually, like another concept came up actually from uh, Kimball. So that is more about um, bus matrix concept on separated data marts, which are combined using conform dimensions, right? So this is actually combined, we can think of that is what those legacy warehouses are, right? I mean, that is a combination of data warehouses, data marts. That's what we call as the legacy systems mostly. And from a technology standpoint, mostly those legacy systems will be either using, say, um, Oracle or Exadata appliance or Teradata. Some are actually using maybe Greenplum, and some other like a SQL Server, etc. Right? Now, back in like around 2010, 11, this big data concept actually came into picture. Even though the actual paper which was done by Google, right, that was back in 2004. But Hadoop mostly came up actually around 2010, 11. And the adoption in the industry started really speaking in around 2012-13. Okay, and that time there was a huge hype around Hadoop and big data. So we had a new concept come in actually like a Hadoop data lake. So this Hadoop based data lake in organizations used to support more cheaper processing, parallel processing, and it actually gave the organizations capability of semi-structured, unstructured data processing as well. And there were actually these new things, new concept came up, which is schema on read, right? So there is no predefined schema where you can actually, you have to store the data, unlike the data warehouses, which were actually schema on write. So this is actually the new thing which came up around 2011, 12, 13 that started. You can think of the main technologies those days were Cloudera, Hortonworks, and Mapper distributions of Hadoop. Then somewhere around 2018 or so, 2018-19, actually this new journey actually started towards the cloud, mainly driven by primarily, I would say, cheaper infrastructure. That is cheaper compute, cheaper storage, etc. That time, the cloud were actually quite basic. Cloud platform services, as we know today, those were quite immature and basic services. But organizations primarily wanted to use the infrastructure to cut down on the cost. So that actually that journey towards the cloud actually started that time. And on cloud, we see basically like both data lake and data warehouse systems. So, for example, on say AWS, right? AWS had a um, data warehouse service, which is a Redshift. And then you have the data lake actually based on S3, S3 storage. But AWS and Azure and other systems, right, cloud systems also offered a native Hadoop-based kind of a service as well, just to ensure that people start moving from their on-premise Hadoop data lakes into the cloud. So, for example, on AWS, you have the EMR system. Then in Azure, we had the HD Insight, which is no longer there, but it was actually the Hadoop distribution from a Azure cloud. So basically, you will see like that was more like a fragmented. Somewhere you have the data lake on cloud, somewhere you have the data warehouse. People were actually trying to move either the data warehouse or the data lake they had on the cloud. Okay, primarily with the hope of actually cutting down the cost. Then came actually the new architecture paradigm, which is basically we call as a data lakehouse. So this is a kind of, you can think of a best of the breed of both the data warehouse and data lake combined together. So into a cohesive architecture, right? Um, so this is basically the thing is that when we were actually moving piece by piece from legacy data warehouse to cloud data warehouse, or legacy Hadoop to cloud data lake. Primarily, it was actually done as a replatforming. That is basically like we are moving these systems, not entirely redesigning the systems, but we are actually kind of moving into just a new technology platforms. With this lakehouse, actually, we see that more effort is actually, or more focus is on the re-architecting, so that we can leverage this architecture pattern, so that actually we are not stuck with the two separate silos of data lake and data warehouse. Now, this is the basically evolution, right? And when we see that the comparison of data warehouse, data lake, lake house, I will not actually read it out, but overall, just a summary, right? I mean, uh, mostly on the data warehouse side, we see basically like the data being structured. The schema was schema on, right? That is already defined schema. You have to write it into the schema. You cannot violate the schema, right? Storage cost was very high. Then you have performance for BI SQL was quite high. Data processing was mostly done ETL, but there were some ELT as well, like on platforms like Teradata. Governance purely on the data warehouse side was actually strong, but not exactly. There's a broad definition of data governance. So when it comes to catalog and other things, that those were mostly not very mature. So overall, actually, like and I think there was actually this is a mistake. This is should not be snowflake. Anyway, so then actually there on the data lake side, we have the structured, semi-structured, unstructured, all type of data. You have schema on read, storage cost was low, and all these things. I mean, mostly the data processing used the ELT framework. Governance was pretty weak, and it normally did support ACID transaction. Later versions actually started to have a limited versions of ACID transaction support. Scalability was quite high. And on the data lakehouse, actually, you have structured, semi-structured, unstructured, everything. More or less, if you compare the parameters, the data lake and data lakehouse will be pretty much similar in this thing. Um, but here, actually, the combination of a data lakehouse which provides the best capabilities of both data warehouse and data lake. That is actually what makes it more attractive. Right? Now, we first actually see what is a data mesh. Okay. So data mesh, when we say about data mesh, so this is actually more about, this is not a technology concept. Okay. So this is about how you actually move into more federated, you can say like a development process and federated ownership, federated governance. So if you see like what are the four principles of a federated data management architecture, which is the data mesh architecture. So the four principles are basically around federated domain driven architecture. Then the concept of data as a product thinking of to the data, and then you have self-service data infra as a platform and federated computational governance. So this is the four principles. And what is the real difference actually we see from the earlier systems? So earlier, basically, we had this enterprise data management, and now we are actually saying that we are moving towards domain data management with the enterprise collaboration. Okay. So here we have different domains. So for example, sales marketing might be a domain, finance is a domain, HR is a domain, supply chain is a domain. So these are different domains. Now each domain has its own kind of a team, which are actually business IT team. Okay, so this is the combination of a business as well as IT, and they own these domains, uh, the data product development as well as any analytic development, that is entirely owned by these different domains. Okay, so what they actually produce, whether it is a data product or analytical product, is entirely owned by the federated domain oriented teams itself, which is not the case with the earlier versions of a data lake or data lake house even actually, which are centralized teams actually working on from data foundation right up to basically like the analytics. Okay, so this is the primary difference. Now, when it comes to say data mesh, so what it actually addresses the shortcomings of a current and previous generation of data lakes and data warehouses. It enables better connection between producers and consumers. So what is producer and consumer? Simply, basically, you can think of a producer and consumer are nothing but different domains itself. So, for example, I as a domain owner for sales, I am actually producing a data product, right? So I am the producer. And if basically supply chain is actually requesting for that same data product, either fully or partially, then basically they are the consumer domains. So basically it's a collaboration of different enterprise domains. And the very important part is then I think many of you might actually have this question that, okay, if everyone actually does their own thing on their own, then what about the consistency or standardization or governance process, right? So basically the thing is that you will see like there is a federated governance concept. So there is a central governance committee. They create these policies and they apply it on the all the federated teams, so that basically even though the entire ownership lies with the federated domain teams, but they are still following the common standards, common guidelines, best practices. So when developing these data products or analytical products, right? So domain-focused data engineering teams, ownership of the data lies with the within resides with the domain experts and aligned with the FAIR principles. So data mesh architecture, data mesh can be considered as a convergence of a building blocks such as data product thinking, domain-driven design, data platform services, and federated governance. Now, I just have a sample from a AWS implementation just to visualize. I mean, for those who may not be able to visualize what is actually like all these things, right? What we are talking about. So, what we are actually talking about is there is a centralized kind of a foundation. So, for example, the data foundation, when we say we are actually taking data from say n number of data sources, right? There can be a number of ERP, CRM, PLM, or other applications, data files, public data sources, third-party data sources, SaaS data product sources, IoT data sources. So there are n number of sources. So we are actually collecting the data from all these different sources, putting into the initial landing, and then we are actually doing the curation, etc., right? So that is basically the data foundation. Till this data foundation, it is actually like a we are not segregating by the domains. Okay, so we are actually having a enterprise common model in the curation, and in the landing, etc., it's actually more source oriented, right? Now, then basically, when you have the central kind of a data foundation and you have the centralized data catalog, all these different producers actually or consumers, these are all different domains, right? So they are actually kind of taking the data from this central data foundation, and then basically they are applying their own data processing on their basically like you can say their own data marts or their own semantic layer solutions. They are creating their own data products. Then they are also creating their own analytical products, which may be a report or dashboard or ML model or anything, right? So entire thing is actually owned by these teams. And what is actually happening is that we have this federated data catalog, which is using Blue Catalog behind the scenes mainly. Um, and all the data governance is actually still managed by the lakehouse formation, actually, the service. Right now, actually, there is also a new service introduced by AWS, which is called Data Zone, right? So, which actually helps with the sharing of this data and common data catalog across these different federated teams. Then it actually generates the business glossary and all those things. So it is actually helping implement the data catalog, sorry, data mesh. But overall, this picture is actually just I wanted to show that how in a typical data mesh you have a central foundation, but after that everything is actually owned by individual kind of a teams, which are business IT teams specific to domains, and they own this domain entirely. Um, and in general, on AWS, for example, there is a separate account created for each of these federated teams. So that there comes basically, as we discussed, right, the self-serve data infra as a platform. So basically, like a and everything that they are using is actually infrastructure as a code, and it is actually blueprinted. So it is just like a spinning up a new account with this platform services and enabling those teams to do their work on an independent basis. Now, lastly, I just put a quick kind of a comparison that when we think about those monolithic systems, whether it is a data lake or data lake house or data warehouse, whatever be it, right? So, what is the problems that uh, that actually kind of is now pushing these different organizations towards a data mesh based kind of a system. So when you see basically like there is a say central team bottlenecks. So central team bottlenecks means basically you have a central IT team which is working for all different domains, and that itself is actually a cause of problems because actually there is no specific focus on any specific domain, and the progress is pretty slow, right? Then slow onboarding of new data sources, um, then poor data quality due to lack of domain context. Single architecture cannot support diverse workloads. Scaling infrastructure centrally becomes expensive, and long development cycles for pipelines, inconsistent metadata and lineage visibility, hard to discover and understand data states, siloed data teams with a limited collaboration, and single point of failure in platform or operations. So, um, again, without going to each and every point, because we do not have time to discuss on details, but the main problems is that in these earlier systems, monolithic systems, you have basically single team, and there is no lack dedicated focus on any specific domains. If these different domains have their own specific requirements, demanding different kind of architecture, different platforms, different specific tools, then that is also not supported by a monolithic system because it is a central system, right? I mean, it's a one size fits all, right? Then collaboration with the business is actually very poor because it is again a central team actually working with 10 different domain owners, and they are simply not actually domain focused, they are more technology focused. Whereas in this new data mesh, right, concepts, so you have the decentralized domains ownership, then you have domain ingest and publish their own data products independently. Then data created and maintained by domain experts ensures accuracy because it is owned by the business domain experts itself, right? So the domain owner is the owner of these different federated kind of a domains. Then polyglot architecture lets domain choose best fit tools. Distributed scaling across a domain increases elasticity and efficiency. Autonomous teams iterate faster with the self-serve tooling. Then federated governance enforces common standards across domains. Data as a product ensures discoverable, documented, and high-quality datasets. Cross-domain interoperability enables shared data across teams. Um, anyway, so this is basically the primary things why the industry is moving towards the data mesh. Not that actually data mesh has no problems of its own. If you do not have a very strong federated governance implemented, then data mesh itself is a disaster, because then your implementation becomes very chaotic with a very lack of security standards, governance. Then you have a lack of sharing between the domains. There is a problem with the consistency, best practices not followed by each team. So it ends up with a total failure, right? So this is a very crucial thing. Second is this data mesh is not really for very small, or I would say small organizations. Typically, this is actually more relevant for medium to large organizations with a standard kind of different domains, with a large user base for different domains. Domains which are actually having its own budget and own kind of operations, everything, and a substantial need for analytics on the domain basis. So they are actually data mesh will be more relevant. Okay. We should not be using data mesh as a silver bullet. So we need to be careful what we are actually kind of proposing, right? Now we go into this, how to adopt data mesh. Again, just to be conscious of the time. So we have 3:45. So I will just be quick on this one. This is not exactly very complicated, but this is how data mesh is adopted. Okay. So if you see basically like it starts with the assessing data mesh fitment and business value, which is like a assess platform capability to alleviate bottlenecks, perform benefit analysis, risk value on the technology, process, stakeholders, etc. Then you mobilize the team for different domains and define data product boundaries, apply ownership of these data products, then set up cross-functional domain teams. Then you have the data mesh development. Then you have to design data products, which involves the data product scope analysis, define data product map, design domain capabilities and data product interfaces, and design data product architecture, and build and scale those data products. So design data product MVP scope, then go into your optimize and onboard other data domains. From a data mesh development life cycles perspective, you first choose the business goal enabled by the data, establish measurement for business success. You second is you define the scope of data products. Third is develop data products actually, and fourth is collect feedback and analyze common needs. Okay, so these are actually the life cycle steps. Now coming into data product oriented design. So this is the fourth and final section of the presentation. So what is data product oriented thinking, right? So we need to think of a data as an asset. Uh, we mostly the technical people, right? I mean, think of a data as in terms of tables, views, etc. Okay, that's a common way of thinking. We think of okay, in either say star schema like a dimension or facts or something. So this is basically like a traditional thinking of okay, so this is we need to have some kind of a table structures, which will facilitate some kind of a reporting or analytics, right? So we do not think of a data as a product. Okay. Um, and we do not have any organizational kind of setup which will actually adopt this product mindset or have any roles such that as a data product owner who has the domain knowledge, who understands what is the actual um, consumption patterns. Okay, because there are many type of data products, but in broad sense, you would say like data products are two categories. One is actually a source-driven data products. Another is the consumer driven data products, and consumption driven data products are much more common because that actually enables the actual consumption. Whereas source driven data products are more normally used from a machine learning standpoint. Okay. Now, domain-driven design actually like the concept of a data mesh is based on domain-driven design, as we have seen. Systems are decomposed into distributed services called microservices, which are built around business domain capabilities. Domains need to host and serve their own domain data sets into more easily consumable ways. And domain teams must fix the ownership and accountability for publishing high quality data to the domains or subdomains where operational data is generated and mastered. And finally, data publishers assume full responsibility for the definition, completeness, timeliness, and accuracy of authoritative data sources by leveraging data engineers within their teams. Now, when we say about data products, these are you can think of these are actually more like in application terms we call microservice paradigm, right? So here basically data products are more you can think of as a microservice in the data terms because it is actually enabling a specific business outcome and driving a specific type of business consumption. Hence, basically, we can think of a data product is actually one is to one linked with a specific business outcome or service. Okay, and this is just a implementation in AWS. I will not go into this as of now. Now, when we think of data products, what are the guiding principles of data products? Because anyone can call anything as a data product? No, right? So there has to be a clear data product guidelines. If you meet those, then only we can call it as a data product. Otherwise, it may be some data asset somewhere, but it is not qualifying as a data product. Okay, so one thing is the first point is that valuable. So the data product needs to support a business outcome or decision. Okay, that's the fundamental thing. It cannot be a generic kind of something that okay, this is a dimension, this is a fact. No, we need to have a data product which is directly linked to a business outcome or decision making. Then you have the accessible. So users and systems access and use seamlessly with existing technical infrastructure. Discoverable. So the data product must be published or registered in enterprise data marketplace and catalogs so that anyone can easily find and understand that. So typically, data products are published along with the data quality metrics, data usage metrics, etc. So that and of course the catalog anyway behind the marketplace, right? I mean anyway provides all the lineage and glossary details. So the fourth point, which is trusted and consistent. Is there a SLA? Can I count on it? To whom do I escalate if there are problems with the data or access? Traditional problem, which I highlighted in the first slide, right? So the data users actually have a less trust on the data because they do not know basically the definition of the data. They cannot see how it is actually processed. What is the problem? What is the exact KPI definition? Or if there is a problem, how do I actually reach out to people for fixing this or clarifying this? So there's no such things, right? I mean, so that is basically the trusted and consistent part of a data product. Everything is documented in marketplace that okay, this is the data domain owner or data product owner, and these are the data usage statistics, this is the data quality metrics, and it keeps on updating those things, right? Then secure compliant, am I seeing only the data issued and not at risk of violating data regulation? That's a very big concern nowadays with all this regulatory compliance coming into picture. Interoperable. So data products cannot be just a hanging on the air, right? I mean, there has to be standards well documented in catalog, and there should be possibility of combining those data products for others easily, right? Understandable, so to consumers understand how to use it, whereas strengths or weaknesses, what are the metadata or annotations. And finally, the addressable part. So after I am approved for access of this data product, can I consume it by dashboard or self-service BI, or call it from a API through a application, or use any AI agent for accessing this data through a, say, MCP server, right? So all this accessible part is actually critical to success, because just having a data product actually makes no sense if you are not able to use it across the different modes of communication. There are different heuristics actually from a set of boundaries and use cases. Again, we are running short of time, so I will just uh, quickly just read it out. There's no time to explain. So align data products to domain business capability, align data products with the possible usage or use cases, align data products with personas or consumers, align data products with the source system, align data products with the consuming dashboard or visualization BI tools, build the data product as a registry for a core business entity, create data products for a coherent group of domain datasets, avoid data products with a canonical model for the whole enterprise, align with the usage contract, and align with organizational boundaries. Data trust actually goes with the data products hand in hand. There are multiple dimensions of a data trust, whether it is the data ownership, comprehension, accuracy, completeness, timeliness, findability, addressability. So all that is actually very, very important, but we will skip this as of now. Finally, the approach and methodology, right? So how do you actually build data products? So we basically build, break this up into three steps. First, we do the definition. So how to identify the data product opportunity, then qualify and prioritize the and define the specifications of the data product. Then we go into build. Okay, so optional step of doing a minimal viable product may be there if it is something with a new concept coming into picture. Maybe you are introducing a new platform or new technology to do this. Then you are actually going to scale it. Okay, so design the and build scalable data product, and then publish the data product on a regional and or local basis. If it is a multi kind of a region kind of a company, right? So then you start with a specific region, and then basically you are doing an enterprise rollout, or you can start with a specific domains and then you can roll out the framework into multiple domains across the enterprise. Finally, you have the operate, which is actually how you optimize, improve, and monitor. So there you enrich, update the data product, do quality control remediations, and monitor usage and consumption. Finally, at the end of the life cycle, when you see the usage actually going down or the different consumption patterns coming in, then you have to retire the data product. Okay. So with this, actually, I will close the presentation. So I will ask for question answers. So we can have like maybe 15 minutes of question answers.
Yeah. So, actually, Arnab, most of the people are on mute or attendees. So there are some
Oh,
questions on the chat. I'll take them for you.
oh, okay.
Yeah, 1 second, just. Okay. So we had someone asking the hardware cost for data storage is capex cost,
Hmm.
amortized over 2 to 3 years. Typically, large scale storage would be less than $1 million. Cloud cost is OpEx storage plus access, the cost multiplies with time. So,
Hmm.
is it true that on prem storage is a problem for enterprise?
Okay. So this is an interesting question. So when it comes to say on-premise storage, we are not actually dealing primarily with the general purpose on-premise storage. We were more focused on the storage which is actually related to the costly appliances. Okay. So whether it is a Teradata systems or say Exadata systems, so the storage and compute used to actually come in as a bundle together. There was no concept of a storage being separate and compute being separate. So if you require say additional capacity of say 5 terabyte, right? So on a cloud, you just provision 5 terabyte of S3 storage or ADLS storage on Azure, but that is not possible when it comes to on-premise systems. So you have to buy half rack, quarter rack, whatever be the system, and that is actually whether you use the compute or not, you have to buy this actually, and that's a very costly thing to buy. So basically, your problem is that you need storage. Maybe you require compute, maybe you do not, but you have to buy that actually in a bundle, and that makes your actually storage pretty costly.
Okay. We have someone, Nilanjan, who asked for slide number 8 on AWS Blueprint. Is Neptune a better choice as a graph database? Slide
Okay,
number 8.
I don't, I don't want to go into specific technology set,
Yeah.
but see, Neptune is a decent enough graph database, I would say,
Okay.
but not that much widely used in the market. So people who are very dedicatedly only using AWS services and don't want to go into any other third-party vendors, etc., for specific systems, or do not want to have the headache of actually managing their own platforms. They are using Neptune, but I don't think that is a market leader. But again, the point here, this topic is actually not
Not on
related to any
product.
specific
It's product.
technology as such.
Correct.
Yes.
Yeah. So the next question is, when DDD becomes central to organizational strategy,
Sorry, sorry,
does it
sorry.
make,
Okay,
sorry,
DDD. Acha, okay.
yeah, DDD becomes central to organizational strategy. Does it make sense for organizations to invest in their own on-prem infra and data platform instead of pushing data to hyperscaler platforms? So what's your view on, I think, yeah, that's the question you are.
See, these are actually okay. That's a very good question. In fact, firstly, your domain-driven design or domain-driven data product delivery, right? These are not actually meant only for cloud. Okay, this is a architecture concept which is actually trying to solve the problem with monolithic designs of a data lake or data lake house. And there are actually implementations on premise for lake house. So it's not like for your data lake house, actually you need to go to cloud. No, you can do that on premise as well. Okay. And people have done that who are actually more into, say, open source kind of a implementation. So they are actually you have a one is to one thing actually, which are just like you have on cloud, right? I mean, you have S3 storage. So you can use the mini of storage actually on your on-premise as well. Okay. So that is basically object storage only. And you can have a comparable kind of a systems which will club together to form a lakehouse. Now, again, whether it is a data lake or data lake house, it doesn't matter. It is a monolithic system where central team is working on all different domains. This is actually data mesh is trying to diversify the actual delivery and ownership and governance into each domain or different teams, okay, which can work independently, own things independently. Now, whether you can do it on premise, yes, 100% you can do. However, this is a very big however. There's a third principle, if you remember, which is basically related to your platform automation. So typically, every federated team is given their own infrastructure or platform which they can independently use, and the cost for that actually segment of the platform is also owned by the the federated teams themselves, the domain teams themselves. So we typically use tagging actually to do cost distribution. Okay, so now doing this on the on-premise, whether it is possible? Yes, it is possible. You can have infrastructure as a code just as well on-premise, but to scale it actually on premise for, say, if you have 15 different domains, creating separate infrastructure platform for each domain is going to be a nightmare actually, because firstly, to have that kind of a scalability of infrastructure platform on premise is a very difficult task. Second thing, it was going to be extremely costly, and that is where actually we typically think of these systems on cloud, but technically whether it is possible on premise, 100%. Why not?
Yeah, I think that's fantastic view. I think we have so many questions. We still have what is data world architecture generally, which is best suited architecture for the data modernization for legacy. And I think we have one more.
Sorry, what is the
We
question? I didn't,
okay.
what is it?
What
Uh,
is data world? Yeah, that's the exact question.
okay, data vault. Okay.
Architecture.
So first of all, okay, data vault um, is a specific pattern of design. Okay. So mostly it follows a very specific data model design pattern. Um, and along with that, of course, your ETL pattern also changes. And data vault is actually very scalable way of designing your data model. Actually, typically data vault is used in your data foundation area, mostly on the, say, curation zone, or in some cases I have also seen like they are actually using in the bronze layer, but anyway, typically used in the silver layer, where it is actually you are forming the enterprise scale data model. Okay. And the benefit of using data vault is actually that with changing schemas of your source systems, where or adding new sources, the impact on your data model is very minimal. It can be handled very easily compared to other type of data model systems design patterns, which is actually much more inflexible. So that is where actually data vault is popular. But again, data vault has its own problem. Actually, data vault is not very suitable from an analytics standpoint. So it's not exactly meant for consumption. So you will see the curation or silver layer might be a data vault implementation, whereas On top of that, there will be a gold layer, or basically the data mart layer, which will be star schema, which is more consumer oriented, right? And then on top of the gold layer, you will have the data products anyway. So that's a different thing. But the thing is that data vault architecture is actually it is actually going on for more than a kind of a 2 decades. And it is still popular, but it's not directly you can say map to data mesh or data products as such. Okay, it's mostly to build the data foundation in a much more scalable manner. Hopefully, I answered the question.
Now
Uh,
we are already 8 minutes over the call,
mm.
so we'll take the last question and then we'll close the session, I think. Um, does the data product has all the information like metadata and is it monolithic and don't need any other data connection? And how will collaboration happen between different domains? I think that's the last question
Okay,
we'll take and we'll close for today.
so so first of all, data product is an entity which is you are designing for your business outcome or your consumption pattern, right? What is actually we are doing different is we are actually making this data product available in the enterprise data catalog, as well as we are publishing into the data marketplace. Now, when we are publishing into catalog, we are also creating the lineage and business glossaries, right? So business glossary is meaning basically all your uh, metrics or KPIs, etc. Critical data elements have your business definitions, right? So when it actually gets published to data marketplace, we also publish along with that the usage stats metrics, as well as your data quality metrics. Now combined together, if you actually are a user or a persona going into a data marketplace to find a data product, right? Or you are actually logging into a data marketplace, doing a NLP based AI search that I want this and this something you write, right? So the AI search actually gives you okay, this is the data products which are available. Now you say that, okay, this is the data product I was looking for. You are anyway, you will actually see also all the data quality metrics, data usage stats, as well as, because behind the scenes of the data marketplace is the actual catalog integrated into marketplace. You can also see your catalog information, lineage information, glossary information. So everything is actually transparent to you as a user. Then you actually when if you have the kind of a now full confidence that yes, I mean, this is what I want to, then you can raise a workflow request for access. It is a automated workflow, goes to the data product owner or the domain owner, and then it actually gets a approved or rejected, whatever be the case. And then if you have the access, basically, then you can also if you remember, there is a addressable thing, right? Then you can have access through multiple channels, whether it is a self-service or through dashboards or through some AI agents, or whether it is actually through some API from a web application. So every possible modes of communication gets open to you for this data product consumption, right? Any other question?
I think we are done on most of it, and we are also over by 10, 12 minutes. Thank you, Arnab, for an interesting session. I think the audience was quite engaging, and there were so many questions. So we'll get a recording, and I'll circulate the same to you. It might be on YouTube as depending upon what CSI supports. So we will you will we once we get it, we'll pass it on to you, all the attendees. Thank you, everyone. Thank you, Arnab.
Thank you.
Have a
Thank you
nice day.
everyone
Bye
for
bye.
participating. Thank you.
Yeah,
Bye.
bye bye.
Have a nice day.